Evening, everyone. I'm Isaac. I work at Steadfast Technologies on the Insurebot team, and I thought this evening I'd take you guys through one of our consumer-facing AI features that we've built that's live for production users and not a chatbot. We've seen the enormous benefits that AI can have for us as developers, but I thought it'd be interesting to talk about what it can do for regular people who don't interface with this stuff all the time, and what it takes to build something that is functional and reliable for high-stakes environments like finance, which is where we operate. So to start, a bit of a background in what Insurebot is and then what this feature does. I'll give you a demo. So Insurebot is probably best thought of as if you know what Compare the Market is, where you fill out one form and it goes to a number of different insurers. We provide a similar situation for insurance brokers. So you have one really big form that you fill out. This one's for home and contents. You fill out all your risk questions like your, You've got your address and what type of cover you want and all that kind of information. And then we go off to a number of different insurers and retrieve quotes, and then brokers can then make decisions that they want to pass on to their consumers. So that's what we do. Jack has actually done a really interesting breakdown as to the technical component of how we do that, because we interface with some really old systems. But for the purpose of this presentation, what's key is this form here, which is bigger than any individual insurer's forms. As you can imagine, if we're going to, I think we go between 7 to 10 different insurers. We have a number of questions. Some of them are common across all of them, like the address of the home. Obviously, everyone's going to ask for that. But then there's some more niche questions like, what is the length of fencing at the property, which maybe only one or two insurers is going to ask, and is really tedious for everyone to fill out all the time. So a big piece of friction that we have at Insurebot is onboarding people who are used to maybe only going to one or two insurers and then have to spend a lot of time filling out this big form. And it's more effort to go to us than it is to go to just Allianz or just one of the other insurers. Obviously, you get 6 quotes in return, but it's still a bit of a learning curve. So one of the things that we were thinking about doing is, what if you could take an existing policy document that you've got and give it to one of these forms and go, here, I just want this insurance that I already have, but for the upcoming year. And we were experimenting with how you could do this with AI when the agentic browsers like Atlas came out, and getting the AI to fill out all of the questions itself, just as a proof of concept. And it works really neat. It works really well. So we've built this intelligent autofill feature. So you take in a policy schedule that you've got. So this, in this case, is my insurance certificate from my car from a few years ago. And then we select which one we want. In this case, we want private motor. And it will go off behind the scenes. So this is the contents of this document here. It's got obviously what I'm covered for, but then it's also got some key information like where I was living, the kind of like where the vehicle was stored and all this kind of stuff. So typically a broker would take this kind of information and manually transcribe it into a form, or they would communicate directly with their client to do that. Instead, we can cut that down to a really short, you just upload an existing document. It pulls a lot of the information we've got here, so address, the rego number. If we continue to the form, it opens up this form and fills in components, including doing lookups against APIs that we already have to validate that the address, the rego number, and all that kind of stuff actually exists. And you can see all of the fields down the right here, ones that have been filled using AI. And this is from a couple of years ago, so we just updated that. So that's what the AI is doing. It's saving a huge amount of time. But it raises a couple of questions. The first being, why would you want to use AI for this task? And there's 2 sub-questions to that. The first is, why do you want to use AI for content extraction? So that is getting the text from the PDF and turning it into something a machine can understand. And then, why would you want to use AI to go from the questions that the insurers have answered to the questions that we have on our forms? There are existing text extraction solutions. AWS makes one. It's called Textract, and it even has LLM provided things. We experimented with Textract when we were building this, but we found it's very good for closed domain documents, stuff like driver's licenses, where you've got they're basically the same. They've got the same information wherever you're going. They're all in the same layout. Where it really struggles is in these open documents. You can see that's another example of a policy document that looks completely different from the one that I was using before. And LLMs give you the flexibility to be able to pull that information from anything. And then they give you the flexibility to be able to transform that information into the format that we have. They're fundamentally at the base level the same information. They're just asked in different ways, and we can sort of emulate the human intelligence required to go from one format to the other. The other thing is frontier AI models now read PDFs directly, so we can actually just upload a PDF, and whether or not it pulls out as an image or as a Word document or whatever it is under the hood, the AI can read it, and it has spatial awareness that stuff like Textract can actually struggle with. You can see here we've got some dense tables. This isn't the densest that you see, but you can see some really gnarly tables in some of these schedules that are really difficult for services like Textract that use traditional LLMs, traditional machine learning to pull from, because they're they're too dense. So yeah, they're much better document converters. So now we know that we're using AI, how do we get it to do this? So the first thing we feed it is the PDF in verbatim base64. We just upload it to S3, and then as part of the Bedrock call, we just feed it that S3 file. But we have a number of other things. So this is FormKit, which is the data structure version of that form that you saw. So it's stored as a giant JSON array that we make in JavaScript and use that as the IDE. So it's got all the information we need to feed it to a human, and we just render it as a form, but you can render it as a document field or as input to the LLM. So what we do is we take a sort of simplified version of this. We strip out stuff we don't need, like validators. An LLM doesn't really need that. And then we can feed the LLM extra information to help it fill out the forms. So in this case, we have a number of different styles of additional instructions that we attach for LLMs. So in this case, we have an instruction for how we want it to format dates. And this is applied to every date field. So anywhere that we choose to import a date, we have it. And then we have a how to answer this specific question. So in this case, this is that policy start date question. And it goes, okay, the schedule that you've got is for last year. So what you want to assume is that the start date of the next one will be when the policy schedule that you've got is done. And it can't be any more than 40 days from today. We can also use it to program in even more specific knowledge if we know that a specific insurer asks or answers things in a specific way that our form translates with. Maybe there's a common pattern that a lot of brokers follow. We can help fine-tune the model with that. And then we can also provide an example response, essentially. So this gives the LLM the JSON structure that it needs to return in order for our model, our regular code, to understand its response. So in instances like this, where we've got a details list, this on our end is stored as a JSON object with a number of key value pairs. So we give it this example that it needs to respond with, as well as its instructions. And so for the really big ones, like the driver fields, we provide really big versions of exactly the same thing. And this works surprisingly well. We don't have any issues getting JSON out of the models. They follow this pretty well once you get to a decent intelligence tier with them. So we feed all that information in to the black box that is AI. And what we get back out is an object that is a list of answers. So a good analogy for this is to think of, we've handed the AI a quiz, and we've got it to provide its answers. So for each one, we have an input ID that just maps to the input ID over here. Its answer, which is in the form that we want it to be. And then we have this confidence meter here This is not, it's important to realize this is not like a traditional machine learning where this is some mathematical thing. This is essentially a second step where we ask the model, hey, you've just provided this answer, how confident do you feel? It doesn't really mean anything in reality, but it's a good gauge. We've found that Claude Sonnet 4.6, the model that we use and trained the system on, has a confidence threshold for things that it's guessing at about 60. So we can basically rule a line at 60 and go, anything at or below this threshold, just get rid of it, because the model thinks that it's guessing. And so this provides us a programmatic way to rule a line in the sand where accuracy falls off a cliff and just get rid of everything and then just require that humans fill in whatever it doesn't answer. You can also provide here like a reason, which is pretty common in tasks like this, where you get it to provide a small little paragraph of why it chose the answer that it did. It's a good way to debug, like why, if it's making a mistake, why is it making a mistake? If it's providing a low confidence answer on something that it's getting correct, why is it doing that? Or you can ask the model to think. We don't do that here because we already run over several thousand output tokens, so we kind of conserve it where we can. And we found the reasoning doesn't really improve the performance, which it can. So we get that, and then we sort of evaluate that. So we have a testing framework that we've built where we have, I think we've got like 30 test cases initially, where we sort of ran the system over that with a number of different models and assessed its output. So you've got what it gets correct and what it gets incorrect, which is fairly obvious as to what's happening there. But unanswered is an interesting one. Because when you're writing systems like this, if you optimize from the most correctness, you sort of implicitly encourage the system to make guesses. As if you said, hey, it's like a multi-choice question, like quiz that you get. It's like, if you don't know the answer, just pick one of them. You're bound to get something. You got a 1 in 4 chance or something. The problem with this is we're dealing with financial data, which you don't want to be guessing. So we have this unanswered as a way for the model to provide an out. As we say, you can choose to not answer this if you're not confident, or we can get rid of it using our confidence threshold. And that provides a really good way for the model to not optimize for being the most correct, but optimize for being the least incorrect. And so our test data has specific cases where we've looked at the PDF that we feed into the model and we go, okay, well, you're not going to be able to answer all of these different questions. So it will consider it correct if it answers something that the ground truth data, like our manually built answers that we provide. If the model matches one of our answers, then we go, cool, that's correct. And if we have a situation where we haven't answered because we know that the model won't have enough information to answer, and the model also doesn't answer, then great. If the model gets something wrong, so our ground truth has an answer that doesn't match what the AI has provided, then that's wrong, obviously. But also, if the AI provides an answer in a case where the test data doesn't provide an answer, then it's guessed, because we know that it shouldn't have enough context to fill it in. And we treat that as incorrect because it's bad. In cases where you're okay with the system guessing, maybe that's fine. And then unanswered is where the test data contains an answer, but the LLM didn't provide an answer. And that article has a lot more information into how exactly we tested it. But so that's how we test it. And we run that as a sort of like unit test type situation where we just make a heap of calls out to the model and then we evaluate it based on our own responses. So you can see here, Claude Sonnet 4.6, which is what we built it on and what it currently runs on, has a correct percentage of 86.9% and an unanswered percentage of 9.8%, which results in roughly 95 to 96% accuracy. With a 3.3% inaccuracy, and it takes, on average, about 18 seconds. You can see we can get that average time down, but at the cost of correctness. Claude Haiku gets a lot of stuff wrong. It's only got about a 70% accuracy rate, and then the AWS Nova models do not do very well. I don't know if I'm allowed to say that at an event like this, but they're not particularly good. There's a few caveats to these results. It was built and trained on Sonnet 4.6, so what that means is a lot of our instructions are tailored towards the way that it thinks. We've actually tested it with Sonnet 5 and Opus 4.8, and it performs worse because it's not, like some of our instructions are really tailored to the way that it works. One of the goals I have is that when Anthropic eventually releases a new haiku, that we'll move to that, because I think with, like, that gap looks huge, but I think with like a week of fine-tuning of our instructions that we feed into the model, we could get pretty good results. But haiku is unfortunately too stupid right now, so we've just sort of left it at Sonnet. And then I think lastly, I have some thoughts on UI. When I went into this project, I thought we really didn't want to advertise it as an AI product because everyone has AI products all the time, and I was kind of getting sick of seeing them everywhere all the time as well. But I think there's some value in doing it. So we have this consistent sort of gradient. It's inspired very heavily by the previous iteration of Apple Intelligence, not the current one because they changed it again. But it's sort of the AI has been here and done this task. And the big reason for that is to indicate to people all across the application, double check what's happening here. Because even though we put in a lot of time and energy to making sure that this is correct, it might not be. And it really, like, you have to double check it. It's a time-saving device, but ultimately this is people's insurance information, so be careful with it. And yeah, I have some off-the-head numbers in usage. So we had, I think today we had 150 forms like this filled out of, I think, something like 700 to 800 actual quotes submitted for processing. So, so it's roughly like 1 in every 6 quotes that we process now uses this as a system to import data. Which is really cool. And we paid, I think this month, we're paying just shy of $300 in Sonnet 4.6 across this feature and another one, which is pretty good. I
think it's 3 cents a bottle.
Yeah, so it works out to be about 3 cents each. Yeah. So, yeah. USD. And we also keep everything on shore here in Australia, which is one of the reasons we haven't moved to Sonnet 5, is it's only available in global inference models. We use Sonnet 4.6 in Australia only to make sure that user data never leaves Australia. So anyway, some closing thoughts. AI is pretty good at nuanced conversions that used to take massive rule sets. I'm sure someone would have been able to build a huge rule set to do something similar to this, but it's not maintainable for a team of our size. And it's really good with atomic, predictable, and accessible tasks that work best. Like they're the best things to start with. If you want more, like a better explanation as to how to optimize those models to do the work, Apple's WWDC from this year has some really great resources on how to train them. Not only to do what these are quantitative tasks where you can run them like unit tests, but there's other cases where you might have a greenfield output where it requires a human to sort of reason over it to think, okay, is this the right output? It's not something you can assess with a yes or no. Apple has done some really good presentations in using AI to assess AI, which is crazy until you realize how useful it is for doing that. But they're better explainers of that stuff than me, so they have a lot of really cool resources on that. And yeah, pick when you communicate AI features wisely. It's useful for safety reasons to tell people what's happening, but don't overdo it. Don't be like Microsoft. And it will make mistakes. A big thing that you've got to do is minimize the possibility of damage. So something I didn't touch on is, like, FormKit has all those validators built into it. So even after it comes out of the AI model, we can run it through our old code validators to be like, okay, is it just providing a nonsense answer that this like select input doesn't support? Well, then we'll get rid of it and just let a human fill it out. So we have a lot of, not guardrails in the AWS product sense, but guardrails in the making it do the right thing sense to making it work. And I think these same principles apply to agentic AI as well. Doing small atomic tasks, even if it's operating autonomously, is much easier to error check before something terribly wrong happens. So, yeah, that's all from me. That's us. So, any questions?
Questions?
Oh, yeah.
I've got 2 questions. If that's right. First one, the instructions you give to the LLM. Do you have any issues with it cooperating? Like, for example, if you provided a JSON schema for the output you want, and then you could use tool calls instead of it spitting out the JSON, then you can run your JSON validation sort of in the harness to read back that error.
Yeah.
The second one was, I'm not sure about Bedrock, but it seems like some of these models have a lifetime. Providers will call out some of the AI models. You said it doesn't work as good with the newer models.
Yeah.
So from a business perspective, that's a bit of risk putting all your eggs in one model that you don't control.
Yeah. Yeah.
So I guess how are you approaching that sort of in general?
Yeah, sure. To answer the JSON question, so it uses, Bedrock has a tool call feature where we can output it. So I think that forces it into being JSON and then also forces it into the specific schema that we want. So we provide like a basic output schema of input ID, answer, confidence, and it basically ensures that it always returns like that. I think we were running it without the tool call at one point, and it was having some validation errors occasionally, so we switched to doing that. And that has worked pretty much flawlessly since. And on the maintenance thing, that is a concern. So there are a few things you can do to improve the responses. Having a number between 0 and 100 for confidence is really wide-ranging. A lot of assessment, like a lot of ways that it's done now, is a number between 1 and 4. Where it's very small, and then you can provide exactly what each criteria is. So like 1 is, so you can do that. And then you make it 1 to 4 or an even number so that it can't sit in the middle and be indecisive about it, because these models love to be indecisive. And a lot of the reasons that it doesn't work for newer models, I think, is down to how we instruct it. Like, I built it with Sonnet 4.6 at the time, and it's like our system prompt is very, very small, because we at the time wrote it very just as we were going, and it's worked really well so far. But when Sonnet 5 becomes available in Australia, that is part of the task we want to do, is change that assessment method and then also make it so that we can literally just swap in models, because the theory should be if you give it to like Opus or Fable, it should be better. There's no reason that it should be worse. So that's a bit of improvement, and you do that like through improving the system prompt and getting it really, really precise. And it's part of the reason I think that Haiku doesn't work as well, is because we have a really open-ended system prompt, and it just happens to work with Sonnet, but it doesn't really work with the other ones as well. So, yeah. Any other questions? Sure.
So I mentioned early on the LLM's sort of handling the document itself when it's like processing and that. And you mentioned in terms of how do you handle, I guess, so they can obviously either come in a PDF or with PDF image or text and that kind of stuff. And I guess handling the context of that text either being, it's a table, it's a text and that kind of thing. Especially if I guess then it kicks over to like an image or something like that, or maybe it's a scan that's garbled or that kind of thing. Are you just relying on the model for that, or?
Pretty much, yeah. We experimented with putting it through TextRact, so we were always going to have the LLM be the from data to FormKit step, but we experimented with having TextRact do the pulling it from the PDF into data that we just feed into AI. Some of the limitations we encountered with that is that the models can just take it. Like the Claude models specifically at the time were the only ones that you could just throw a document at it and it would just handle it. And they're uniquely decent at pulling PDFs where you can't select the text So they're like functionally an image where they can still reason over that, whereas Textract actually like just completely discards that in some cases. So we found that it was better performance-wise than Textract, and then Textract costs money per page and inference and stuff. So we found just letting the model handle everything works surprisingly well. I think you attempted a couple, it was like last week, I think, you took a photo of
Wrote
your...
it out by hand, took a photo, copied the photo into a Word document, saved the Word document as a PDF, and then it extracted it perfectly.
Yeah.
And that was just the model, wasn't it? You haven't added anything.
No, yeah, that's just the model doing it.
Put any guardrails around, like, say someone gives here's my summary thing, but also like attaches the entire PDS to it, right, as well.
I think we have,
like, just so it's not taking in like 400 pages of context.
We have guardrails on the maximum length that it can be. I think we limit it to something like 30 pages, which prevents you from having runaway input token cost. So yeah, that's probably the best way we do that. Yeah. Oh, sure.
Did you think about the possibility to upload two documents like from past year and year before and have like information?
Yeah, so we thought about that. The system, like everywhere up until the user interface, supports multiple documents. Like if you access an API endpoint, we decided to limit it to one from a sort of user experience perspective. We thought if a broker had uploaded two different documents with conflicting information, first of all, how do you instruct the model to pick which information should be preferred? Do you go based on which is the latest document? And then also, how do you communicate that to a broker where that source is coming from? If the conflict resolution we chose doesn't match what a person thinks, how do you tell someone that? And the complexity was just too high. And I think the benefit of just being able to upload one document is pretty good. A big piece of this feature is we also pull down data from documents from a bigger Steadfast-owned service that keeps all of these PDSs, and they store, not PDSs, schedules. They store one schedule per policy transaction. So a lot of people are just pulling directly from that app into ours to upload to then keep going. So there isn't a need from that flow for multiple documents. So yeah.
Why do you get leave?
I don't think so. He puts on Queensland gear for the state of origin though. We have a couple of different outfits for him throughout the year, but he does not get leave, no. Sure.
And I think that in previous experiences, I haven't used the Sonic, but like when you try and give it an out so that it could, like reason itself to say, oh, it's maybe not correct or I'm uncertain. They just optimize for being correct. Like, did you have to move around with the prompt or change to that, or was it really?
Yeah, so there is an element, like when you're writing this stuff, of like building the test suite is really useful early on because you can just hit a command and then it just runs like 30 or 90 test cases or whatever you're doing. So you can really easily check the differences in your prompts. But yeah, we did have some refining in it, like choosing the wrong answer or even when it was optimizing for guessing stuff. So that's one of the other benefits of that confidence meter is we found, and it does this for pretty much every document, it'll make a sort of like leap of logic where it'll be like, this is what the original document has, but this document has a tangentially related question. I'm going to infer the answer based on that. And Sonnet specifically, and this changes model to model, ranks that at a confidence of 60. So by providing that method of feedback, and I'd probably recommend going a 1-to-4 ratio, and then specifically saying, if you're making a guess, put that at a 2, or something like that. But yeah, we can just filter out those guesses. So we saw, and you can run it without the filter out, and then you can see, okay, well, everything that has a confidence of 60, like 7 out of 10 of those answers are wrong, so you just get rid of them. So that's kind of how we solved that, largely.
Plus the
Yeah, plus the refining of prompts and stuff.
how do you feel like graceful if the wrong PDF?
It will return, so if it can't provide any useful answers, it will just provide a empty array, and then the UI will take over and be like, well, we couldn't find anything here. Sorry, try a different document.
For your the test suite and evaluation, I guess the ground truth stuff that you build on top of, is it all real data or is it generated data or?
It is plausible but fake data. So we ran Insurebot against a number of insurers and then downloaded the policy schedules that they generated using information that you have to fill out our form, so it has to be valid, right? And has a real address and stuff, but it's not actual PII. We didn't download a bunch of customer data to train the model. So it's plausible in the sense that it has to be valid and it's downloaded from the actual insurers, so it's the kind of data that people are going to be feeding into the model. It's just not real human PII. Yeah.
So the ones you found where it was making errors, was that it getting you still think it was a high?
Sometimes, and that's part of the sort of training process, is if it's getting it wrong but it has a really high confidence, then you can go, okay, well, why are you making that guess? And in a lot of cases we found that the prompt for that specific question, so we've got little system prompts next to every question, wasn't strong enough. It wasn't we sort of yell at the model to get it to provide the right answer. And we've found that it wasn't stern enough with the model, and so it was making guesses, or it was thinking of the wrong data and stuff like that. So as part of that training process is refining those little prompts. Yeah. Sure.
Yeah, you're always saying train model, but you actually train your prompt to work with specific model.
Yeah.
Have you considered to use some actually train the model or have some foundational model, for example, and train it before it was possible only with the American Mark? Is it already generally available to train models in quick way?
Yeah, in the RLFT of Bedrock.
Yeah, because I'm not sure if it's under NDA.
Oh, there's one of the releases.
We talked about it. We released a capability where you can take them over and you can train it further with your data. Is it GA? No. Can you take an open weight model right now and train it further on your data? Absolutely can.
The one since we played with train the Nova Light for rain. Is it available already?
It's available, but it's kind of limited stuff, right? So it's not fully GA.
So it's the next step to improve.
Yeah. We built this feature reasonably quickly, so we sort of thought, what could we take off the shelf? And we've gotten surprisingly good results. And so we didn't really feel the need to build our own model. And we probably wouldn't have done the feature if we had to train our own model.
It's not train the model from scratch. It's fine-tuning.
Fine-tuning. Yeah. And so we probably don't have the time or capacity to do it. We probably just wouldn't have done the feature if we. It was kind of one of those things where we were experimenting with it. We found that it worked really well, and we were like, okay, cool. We'll build this into a feature really quickly just to prove that it's possible, and it works really well. But if it was, that's why I say with the rule sets, it's if we had to build out that huge rule set to make that possible with traditional machine learning, we just wouldn't have done it. It's not worth the time on our end. We've got other things. So yeah, sure.
What type of observability have you built sort of around this? You've obviously, got a lot of stuff going through. It matters. How are you monitoring it? How are you picking out where it goes wrong and how to improve it and that kind of thing? But I guess more so in the real world live environment.
Sure. So we don't keep any of the information that it runs. We don't log anything like that. We rely on, we have a pretty close relationship with the brokers that we service, so we rely on them. And we did a pilot group and run pretty closely with them to see if they found any issues, and they haven't, as far as we're aware. But in terms of like assessing in production, we don't. We currently use it as a temperature of 0. So to me, that is my way of guaranteeing what we're seeing in test results is pretty well indicative of what we're seeing in production. I think setting temperature to 0 goes away with all the new models like the Sonnet and Fable 5. You can't control temperature anymore. So yeah, that more tells us like usage amounts. So like when something happens, and then if it encounters an error, like it runs for too long or it returns nothing useful, then we know about that, but we don't know what it returns. We've thought about implementing a sort of like assessment thing, is like running off the back of that is taking, like getting Claude Opus, like a smarter model to assess the outputs on the fly for some of them, but we haven't really built it and we haven't had any reports that anything's going wrong, so we kind of haven't felt the need to.
So in the end of the day, though, also, I guess your validation's all on Brogo, right?
Yeah.
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 Just like that, well, we do split out some real small existing products for using different models. But there's ones that work really well before, so keep that and then go, oh, these ones are constantly failing.
Maybe. I don't know. We kind of have the benefit at the moment of everything runs through the same model, and so we save a lot of cost by having it just run all at once. We had thought about doing like one step, like we have the AI do, and we were thinking about getting Haiku to do this, is go from PDF to like a latent data model and then feeding that latent data model into a translation one. So you have 2 separate AI steps. What we found is it's actually cheaper and more efficient to just use one model to do everything all at once. And so you just get it to go from PDF to output all at one time. It's quicker. It works out cheaper because then you're not paying for output tokens on one and then input tokens on the other. And
It's all one shot.
Yeah.
Yeah, okay.
And no reasoning or anything as well.
Yeah.
So it has no opportunity to do any other sort of agentic reasoning that that Copilot and all of those ones do. It's just in and then out. Yeah.
Paper on reasoning?
Sorry?
You read Apple's paper on reasoning?
I
Probably
don't
a good
think
thing.
Oh yeah, sure.
Do you do any front-end analytics? So you can say you did 150 everything. This functionality was used 150 times today, but do you understand the effectiveness of it? So do you correlate between the LLM response and then someone replacing the value pretty quickly?
We don't do that, and that would be a really interesting thing to track. We have a basic one that just detects how many times it works, how many times it returns nothing, but we don't do anything more in detail than that. But
I think that's probably the best feedback. And then you can see if your confidence number
matches it. Yeah, definitely. Yeah, it'd be a cool thing to build.
And you don't have to worry about the data either. It's just
Yeah.
a signal of did they change it.
Yeah.
Well, how much do they
Yeah.
change, but you don't control the model, so
Yeah.
you can't do reinforcement.
Yeah. You could still do, like you could refine the system based on that, which is, sort of a step of abstraction removed from actually training the model, is you can still do training on the data you feed it. But yeah, that's a good idea, actually. That would be cool to build.
How long did it take you to build?
We got the proof of concept, so the initial thing done, it was about 2 weeks. Then we presented it to people at Steadfast, and then we went away and built the data, the sort of test suite for it, and then validated that what we were doing worked. And it's good that we did that step because we were making a lot of assumptions that didn't hold up on a larger test set. And so I think overall that took about 2 months from idea to go live. Yeah, that's true. Yeah, and then, So, it didn't take all that long.
Can I just ask, if you were scaling this, so instead of getting 100 of these a day, you're getting 100,000. At the moment, you've got a linear cost model. So, I think at the end, other areas in your scaling that you look for procedure places where procedural patterns that will allow sort of shortcuts to reduce, so instead of being scaling linear, it actually scaling drop off. Be a great problem to have, though.
Yeah. I don't know. We haven't really faced that issue because we don't use a subscription model. We pay per one of these things processed. So our income scales at the same rate as the expenditure that we spend on the AI, and the AI is a fraction of what we make per quote. So it's sort of it's a cost we're willing to live with at the moment. And we won't scale to 100,000 users. Like, there just aren't that many brokers in Australia, so it's fine. But yeah, it's an interesting thought to sort of think about. Like, these things are expensive to run at scale. And that's just the reality of it. Like, you can try running it on a lesser model like Haiku, but you run into limitations in what they're able to read. Like, they make mistakes when they're transcribing, and their reasoning capability goes down, and all of that kind of stuff. So, yeah.
I was just thinking about, because there's going to be X number of different types of templates, the insurance what you're getting, and if that can be recognised, is that able to put shortcuts so that doesn't have to go through to almost treat every single document like it's an entity document, which I think is currently doing.
Yeah.
Yeah, there is some the insurance you've got to go to
All classified documents that use a elements.
It's a good system point for which company.
Yeah. You could potentially also do some like pre-processing on the document, which is the thing, like we just feed the raw document in, and like that's obviously pretty common in machine learning, is you do some pre-processing to strip it down as much as you can, which might be worth investigating. We haven't really looked into it. So that might be, yeah. Yeah.
So you thought about building out the capabilities today around certain models? So Sonnet 4.6, probably 4.7, 4.8, in that space. How are you thinking about that model version changing? We've got 5 coming next. It's available already today in regions. The next one's and all that. How are you thinking about system property, managing that moving dynamic of the model changing on you as you go ahead? Have you thought through that?
It'll largely be probably a pretty manual process as well. Like the benefit of the test suite is we can swap out the model that it's running and then run the test suite. So if you go to that QR code, I've got like 10 odd different models that I've run it through, including Sonnet 5 and Opus 4.8. I didn't do Fable, sorry. I didn't want to burn that much money. I didn't want someone yelling at me for that. But it's largely a manual process. Like, we'd have to go in. So once Claude Sonnet's GA in Australia inference servers, then I'll spend probably a week of time fine-tuning. So like taking the results and then trying to get it to be as good, if not better, than our current one. And we'll probably have to do that when we see a new model that is worthy of the upgrade. At the moment, Sonnet 4.6 is still well supported and probably will be for hopefully a year. Yeah. My hope is that the next version of Haiku is good. Its biggest limitation at the moment is it gets that PDF to data step, like the actual extracting of the content of the PDF. It gets stuff wrong. Like, it just misreads characters and stuff, which is its biggest limitation beyond reasoning. Like, reasoning can be fixed, but that is limited. But that would be a worthy upgrade, right? Like, it's faster, like presumably, and then it's also half the cost of what we currently do. So we can go to our users and be like, look, it's half the time, and we can go to everyone who pays the bills and go, look, it's half the cost. But like, going to Sonnet 5 at the moment, we're not in a huge rush because 4.6 works really well, and Sonnet 5 is sort of more expensive depending on what footnotes Anthropic puts in their release documentation. So yeah, we sort of gauge it, like I'll run a test once off to see, is this significantly better? And if it's good enough, then we'll look at upgrading it. Otherwise, we'll just use what we're currently using.
It's kind of a leading question. So you treat it like a moving thing, if you ever good in it.
Yeah.
Treat it like a Python version that is going to change on you.
Yeah.
And work with that.
Yeah.
When you're doing that system prompt, like loop fine tuning kind of thing, how much is that you, and how much is that another AI doing the fine tuning of the system prompt?
I did a lot of it myself for this one. We have another sort of beta AI feature that I worked. I was really stumped on how to do that. That was a lot more greenfield, so rather than filling out a form, it was generating a document. And that raised a lot of questions of how do you assess that, how do you system prompt that, all those kind of questions. So I worked with a Claude agent to help me write a better system prompt for that, and then also to figure out how to assess it and stuff like that. For this project specifically, I did most of it by hand. But it is worth doing because AI models are surprisingly good at knowing how to teach themselves a thing, which is weird, but yeah.
Any more questions? Yeah, I know. But yeah, I think so. Wait.
Thank you.